Hey guys, GCSE STEM here. In today's video, we are going to be covering the topic of atoms. By the end of this video, you should know the definition of an atom, a proton, a neutron, and an electron. And you should be able to understand how to calculate the number of subatomic structures in an atom. If we start off with an atom contains protons, neutrons, and electrons. As we can see from the diagram below, the nucleus is in the middle of an atom, and a nucleus is composed of protons and neutrons. The nucleus of an atom has a radius of about 1 × 10⁻⁻14, or in other words, it's extremely small. It has a positive charge because of its protons. Protons are positively charged, and neutrons are neutrally charged, hence the name neutron. Almost the whole mass of an atom is concentrated in the nucleus. The electrons. As we can see from the diagram from the previous slide, electrons move around the nucleus in electronic shells. In our first electronic shell, which is shaped as a circle, we have 2 electrons. In our second electronic cell, we have 1, 2, 3, 4 electrons. Electrons are negatively charged, hence their minus sign, and are extremely small, but they cover a lot of space. The volume of their orbits determines the size of an atom, which means if an electron orbits a large amount of space, that means the atom will be large as well. And electrons have virtually no mass, meaning they are very, very light subatomic particles. Protons and electrons. Atoms are neutral. They have no charge overall, unlike ions, which is a positively or negatively charged atom. An atom is neutral because they have the same number of protons as electrons. The charge on the electrons is the same size as the charge on the protons, but opposite, so the charge cancels out. Think of it as this. Say we have 11 protons and 11 electrons. They're always going to be the same, so if we do 11 minus 11, we get 0. And 0 is neither positive or negative, it's neutral. In an ion, however, the number of protons doesn't equal the number of electrons. This means that it has an overall charge. For example, an ion with a 4- charge has 4 more electrons than protons. So if we use the previous example, we would do 11 protons minus 15 electrons, and that would give us -4 or 4- charge. If we move on to atomic number and mass number. The nucleus symbol of an atom, which is just this thing here, tells you its atomic proton number and mass number. The atomic number, which is this 11 below, in all cases for any element symbol, tells us how many protons there are. In this case, we see that sodium, which chemical symbol is Na, has 11 protons. If we remember from the previous slide, in an atom, we have the same number of protons as we do electrons. So if we have 11 protons in sodium, we would have 11 electrons as well. The mass number, which is just 23 above, tells you the total number of protons and neutrons in that specific atom. To get the number of neutrons, you subtract the atomic number from the mass number. In this case, we would do 23 minus 11, as 23 is the total of protons and neutrons, and 11 is just the protons. So if we minus them, we should get the number of neutrons. 23 minus 11 is the number of neutrons, and in this case it's 12. As a summary, you should be able to say what atoms are made up of, and that is protons, neutrons, and electrons. The nucleus of an atom is made up of protons and neutrons. You should also know electrons orbit the nucleus in shells. The mass number in an element symbol tells us the total number of protons and neutrons. The atomic number tells us the total number of protons and electrons.